So now we're going to talk about Venn diagrams. So suppose you go shopping for a new laptop. You tell the salesperson that you wish to buy a laptop with a 14-inch display and 4 gigabytes of memory. The salesperson was a bit distracted and thought you said you wanted to buy a laptop with a 14-inch display or 4 gigabytes of memory. Well, which laptops are in the set of laptops with a 14-inch display and 4 gigabytes of memory? And which laptops are in the set of laptops with 14-inch display or 4 gigabytes of memory? The two of them are quite different. In the first part, you could get laptops that are the AND part, which is what you asked for, because you asked for the 14-inch display and the memory. So in the first question, that's exactly what you're looking for. You want both that 14-inch display and the 4 gigabytes memory. But in the second one, where the salesperson thought you said, you either want a 14-inch display or you want the 4 gig of memory. They are two separate parts. They are not the same. So with the difference is that the first involves laptops joined by the word and the second involves laptops joined by the word or. Words such as and or have important meanings in everyday applications, such as ordering from a menu or understanding a legal document. A useful technique for illustrating set relationships is the Venn diagram. So in Venn diagrams, a rectangle usually represents the universal set, or U, and the items inside the rectangle may be divided into subsets of the universal set. So subsets are usually represented by circles, and there are 4 types of subsets. These are disjoint sets. That means that set A and set B have no elements in common. Here's set A, here's set B. They don't touch at all, they don't overlap. So there's no intersection part of it. They are disjoint and they have nothing in common. The second one is subsets. When A is a subset or equal to B, every element of A is also an element of B. So here all of set A is inside of set B. Equal sets is when set A equals set B. That means all of the elements of A are elements of set B, and all elements of set A are elements of set B. And then we have overlapping sets. This is when set A and B have elements in common. So we talked about this in sets. When the overlapping part, that's where they have an intersection. And then the other thing we're going to briefly talk about is the complement. The complement of set A is symbolized by A with a little comma at the top there, an apostrophe. And it is the set of all the elements in the universal set that are not in set A. So if this is set A, that circle is set A. The complement is everything outside of that set. Now recall that the intersection of sets A and B, symbolized A intersect B, is the set containing all the elements that are common to both set A and set B. So we're going to look at some examples. So we're looking at example 1. And if our universal set, so U is equal to A, B, C, D, E, F, and G, and we have set A is equal to A, C, and E. We are looking at a complement. So remember, the complement is everything outside of set A. So all the things in U that are not in A. The universal set has all of these letters, and A has this. So that means our A complement is equal to everything in here minus this part here. So it can't have A, but it will have B because B is not in A, so it will have B. C is in A, so it can't be that one. It'll be D. It can't be E, but it can have F and G. So A complement is everything outside of set A that's in that universal set. And we can draw the Venn diagram that looks like that. So we're going to draw a rectangle. We'll have set U. We'll have set A. And in set A, we have A, C, and E. And in our universal set, we have B and D and F and G. And it doesn't matter where you put them. As long as they're in that square outside of the circle, it doesn't matter exactly where they're placed. This is our A complement right there, is that part right there. Okay? Just so you understand. All right. Example 2, we are letting the universal set U represent the 50 states in the United States. Set A and set B are given below in the table as of 2014. So set A states with a population of more than 10 million people. They have California, Texas, Florida, New York, Illinois, Pennsylvania, Ohio, and Georgia. And set B states with at least one city with a population of more than 1 million people. We have California, Texas, New York, Illinois, Pennsylvania, and Arizona. So we need to determine the intersections of set A and B and illustrate the relationship with a Venn diagram. Recall that their union is what they have all together, and the intersection, of course, is what they have in common. All right, so let's go draw this out. So this will be example 2. And we're going to have a universal set. And we're going to have set A. And we're going to have set B. So this is A and this is B. Now, first, before we write anything in there, we're going to need to figure out what the intersection is and what the union is. All right, so the intersection is what they have in common. So when we're looking at this, they both have California and they both have Texas. So let's start with there. I'm going to use the abbreviations for the states. So California is CA and Texas is TX. And they both have New York, so that's NY. They both have Illinois, that's going to be IL. They both have Pennsylvania, that's PA. And looking at the rest, they have Ohio and Georgia here and Arizona there, so they don't have anything else in common. All right, so that's the intersection. Now, all of the states, we can start with the first set here, and then we'll add anything that's not there. All right, so in set A, we had California and Texas and Florida and New York and Illinois and Pennsylvania and Ohio. I'm kind of running out of space. I'm going to come down here. And Georgia. And down here, we already have California, we already have Texas, we already have New York, Illinois, Pennsylvania. Oh, we need to add Arizona. So that is the union of all of set A and set B. So now we're going to put it into the Venn diagram. So the intersection will be, there are 5 states we need to write in here. I probably should have made my space a little bit bigger, but it's not always in my nature to do so. So we'll squish them in. So we got California and Texas and New York and Illinois and Pennsylvania. So they're kind of squishy in there, but they're in there. You can put commas between them if they look like they're, too close together. And now we have to figure out what was in set A that we don't have already. So we already have California, Texas. Oh, we don't have Florida, so we need to put Florida over here. We already have New York. We already have Illinois and Pennsylvania. We need Ohio. And we need Georgia. All right, for set B, we already have California. We have Texas. We have New York. We have Illinois. We have Pennsylvania. Here we need Arizona. Now, that takes care of what's in A. So I can see here on my Venn diagram, this is all of set A. This is all of set B. I can see the intersection. Now, out here are all the other states. I don't want to write all of the other 41 states because we have 9 taken care of here. So I'm going to write the 41 remaining states because it would be a lot of states to write. Normally what you're going to have as far as homework exercises and that is that you are going to not have something where you're going to write that. But in this case, we're going to do that because there's just a lot of them. All right, let's look at another example. So let's go to example 3. So if we're given that the universal set is 1 through 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and set A is equal to 1, 2, 3, and 8, and set B is 1, 3, 6, 7, and 8. We need to find the intersection, and we need to find the union. So what do they have in common, and what do they have all together? All right, so in common between A and B, we're not looking at the universal set, we're just looking at A and B here. So A intersect B, that's going to be, they both have 1. They both don't have 2, but they both have 3. They both don't have 6 or 7, but they both have 8. Now all together, we can write this again in numerical order, or we can add on. So I'm going to take set A. We've got 1, 2, 3, and 8. So I've got 1, I've got 3, I need to add 6, and I need to add 7. So that would be our union. So now let's draw our Venn diagram. So we've got our universal set. We have set A, we have set B. All right, so our intersection is 1, 3, and 8. Now we're going to go to set A, and we have 1. We don't have 2, but we have 3, and we have 8. For B, we have 1, we have 3, we need 6, we need 7, and we already have 8. So again, I can look at set A. Yep, they're all there. I can look at set B, and yes, they're all there. Don't rewrite them over here because they're already in, if they're already in the intersection. Now I need to put out here everything that is in the universal set that was not in A and B. So I already have 1, I already have 2, I already have 3, I need 4. I don't have 5. I have 6, I have 7, I have 8, I don't have 9, and I don't have 10. And again, you can put those anywhere. They don't have to be all in one specific spot. All right, let's look at another one. So example 4. So we have the universal set. We're going to use the same universal set again. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But this time set A is 1, 2, 4, and 6. And set B is 1, 3, 6, 7, and 9. All right, so A intersect B is what we need to find. and we need to find A union B. So the intersection, again, is what do they have in common? So what they have in common is going to be what they have in common is going to be, sorry, I got locked out of the computer. They both have 1. They both don't have 2 or 3 or 4, but they both have 6. And they don't have 7 or 9 together. And then the union, we can, again, write all of set A, and then we'll add on set B. Or you can put them all in one order. It doesn't matter. So I can write 1, 2, 4, and 6. I already have 1. I need a 3. I already have 6. I need a 7. And I need a 9. So there is my union. And now I'm going to draw my Venn diagram. So I've got my universal set, and I have set A, and I have set B. So A and B, make sure you label them. All right, so what they have in common goes in that middle part where it overlaps. And I go back to set A. I have the 1, but I don't have 2. I don't have 4, but I already have 6. For set B, I have 1, but I don't have 3. I have 6, but I don't have 7, and I don't have 9. Now I go back to my universal set. I have 1, 2, 3, 4. I need a 5. I have a 6. I have a 7. I need an 8. I have a 9, and I need a 10. So that would be what's in your universal set. So really make sure you're doing your intersections, because the intersection is going to help you see what they overlap with. All right, so these were Venn diagrams with 2 parts. So here you can see we've got our Venn diagram with 2 parts, or 2 sets. We've got the part 1 that's in A only. Here we have part 2 is the intersection between them, and part 3 is only what is in B, but not in A, so it doesn't overlap. And then you have what's in the universal set that's not in A and B. Now, when we go to Venn diagrams, so here you have 4 parts. When you go to Venn diagrams with 3 sets, it's actually going to give you 8 parts. So you're going to have what they all have in common, what is in common between 2 sets there, A and B, in common between B and C, in common between A and C, and then what's only in A, only in B, and only in C. And you can see that on the handout, I've got it, it's a little bit highlighted, it's sometimes hard to see, but it's showing you what each of the parts are. Note that when 2 sets overlap, it looks the same shape. So between A and B, the overlapping part is just like what we've had before, except it's going to include 2 parts of your Venn diagram. When you're looking at between A and C, again, it's going to look like it's looked before, but it will have those 2 sections together. So the first thing you want to do, there's some steps here when you're doing the sets with 3 sets. Find the intersection of all of them, and then find the intersections between each of the individual sets, because that will make it easier to do. All right, so let's go look at an example. So this will be example 5. In example 5, we have our universal set. It's going to be 1 through 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Set A will be equal to 1, 5, 8, 9, 10, and 12. Set B is 2, 4, 5, 9, 10, and 13. And C is 1, 3, 5, 8, 9, and 11. All right, so for this, we want to find the intersection between all three sets, the intersection between A and B, the intersection between A and C, and the intersection between B and C. So you have to find 4 intersections when you're doing the 3 sets. I'm not going to have you find the union for all of them because it doesn't serve the purpose in the Venn diagram. I can have you find it, and you can list them all. It's the same kind of union. You'd union all of them together. But for the Venn diagram, this is really what you need. Alrighty, so let's draw out what these actually are. So what do they all have in common? Well, A and C have 1, but B doesn't, so it's not 1. We've got 2, 3, 4. Oh, they all have 5. No 6 or 7. 2 of them have 8, but not all of them. Oh, they all have 9. They don't all have 10, 11, 12, or 13. So 5 and 9 is what they all have in common. Now let's just look at A and B. So we're only looking at the first 2 sets. We are looking, they don't have 1 or 2, 4. They both have 5. Now understand, if they all have 5 and 9 in common, you're going to see 5 and 9 listed here for each overlap. So they both have 5, not 8. They both have 9. They both have 10. And nothing more. All right. And A and C. A intersect C. So what does A and C have? They both have 1. They both have 5. They both have 8. They both have 9. They both don't have anything else. So they have 10, there's 11, there's a 12. All right, and let's look at B and C. So B has, they don't both have 1 or 2 or 3 or 4, they both have 5. They both have a 9. And I'm going to add 1 up here. I'm going to put an 11 inside of that. It doesn't change anything we've done so far. We're going to stick an 11 in B because I realized that they don't have another number and I want them to have that. So, all right, so together they have 5, 9, and 11. So I realized we were missing 11 up there. It doesn't change anything else we've done because it only affects this one down here. All right, so let's draw our Venn diagram. And we could do the union of all of these. You're just going to list all of A at the values of B and the values of C that you need to find in there. I need to draw my box slightly bigger because now I have to draw 3 circles. So 1, 2, and 3. And I'm trying to make my overlaps big enough. And always label your circles. All right, so what do they all have in common? I'm going to write these in black so it's a little easier to see. They all have in common 5 and 9. That's the 2 numbers that all 3 sets have. Now we're looking at A and B. A and B have 5 and 9, but we already have that listed because remember, this part here will be what A and B have in common. They both have 5 and 9, so we'll put the 10 right there. So that's the overlap now between A and B. Between A and C, they have 1. They have 5 already. They have an 8. They have a 9 and already. So this would be the overlap between A and C. And now we need to do B and C. B and C have 5 and 9, and they need they also had 11, so it will go here. Now we'll go back to set A and see what else does set A have. We have a 1, we already have the 5, the 8, the 9, the 10, we need to put a 12 up here. In set B, we have 2, we need a 4, we have the 5, we have the 9, we have the 10, we have the 11, and we need the 13. In set 3, we have the 1, we need the 3, we have the 5, we have the 8, we have the 9, and we have the 11. So in here, now you can see this is all of set C, all of set B, and all of our set A. Now, to put in our universal set, which we didn't label, so let's put a U there, we have to go back. So we have 1, 2, 3, 4, 5. We don't have a 6, so we'll put a 6 here. We don't have a 7. We have the 8, we have the 9, we have the 10, the 11, the 12, the 13. We don't have the 14. So when your numbers are kind of close, like I said before, you can put a comma. If that looks like 18 to you, you could put a comma there. If you think that looks like 59, you could put a comma there to make sure that you understand what the numbers are. Especially like if you have 1 and 2 and that is a 12, you might want to clarify for yourself. But that's how you're going to do a universal with 3 sets going on there. All right, so let's go look at example 6. So for example 6, we are given the Venn diagram. We need to determine the following sets from that diagram. We are given the diagram here, and we need to figure out what set A, B, and C are, and what the universal set is, what A intersect B, A intersect C, B intersects C, and then the intersection of all of them, and then it also says to do the unions. So basically we're going to go backwards. All right, so this is example 6. And I can set that there. You should be able to see that. So we are looking to find the universal set. We need to find set A, set B, and set C. And then we'll find the intersection of all of the sets. And then, oops, I wrote union. The intersection, so sorry about that. I wrote them upside down. The intersection of all the sets. Let me rewrite that because that looks bad. The intersection of all of the sets. The intersection of 2 sets, of another 2 sets, and the last 2 sets. Alrighty, so let's start with, it doesn't really matter where you start. So if we start counting, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can see that all of the numbers 1 through 14 are listed. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So that's my universal set. And now I'm going to write set A. So set A has 1, 3, 4, 5, 9, and 10. And set B has 3, 4, 5, 6, 7, and 8. And then it has 12 and 14. And set C has 4, 5, 6, 8, 9, and 11. All right, so I found those sets. Now let's go find the intersections. Well, the intersection of all of them is right there in the center. It's 4 and 5. Don't forget your curly brackets. The intersection between A and B are these two sections, so it's going to be 3, 4, and 5. The intersection between A and C will be 4, 5, and 9. And the intersection between B and C is 4, 5, 6, and 8. And then you could still go find the union by combining your sets, but I'm not going to do the unions here. But you could still do it off of after you find your A and B, or you can look at it and go all of the union of A and B would be this. The union of B and C is going to be all of these, or you can also look at them from over here. Either way would work.